Good morning, everybody. In this video, we'll be talking about greenhouse gases and feedback loops, both positive and negative feedback loops. We're going to start with the four categories of major greenhouse gases on Earth. And the one that we've spent the most time on and that you've heard of the most is carbon dioxide, CO2. The first thing to keep in mind with regards to the CO2 in the atmosphere is a lot of the percentage of CO2 in the atmosphere is there for natural causes. The cellular respiration that's done by nearly every organism on Earth that uses oxygen is releasing CO2 into the atmosphere. In addition, wildfires and volcanic eruptions are releasing CO2 into the atmosphere. Now, overall, this is all made up for by the fact that there are plenty of organisms doing an inverse amount, the same amount of photosynthesis. So if you take all these natural actions into account, the amount of CO2 going into and out of the atmosphere typically balances out. The problem comes about when you start adding in human impacts. And the human impacts include things like deforestation. And I'm not talking about the deforestation that we did, 100 or 150 or 200 years ago in Europe or in North America. I'm specifically talking right here about the deforestation that people are using just to stay alive in tropical regions. So in Brazil and in the Congo, if somebody's cutting limbs off of a tree in order to cook their food to stay alive, or if they're cutting down an area of trees so they can grow food to live. This is a significant amount of deforestation happening on Earth currently each year. In addition, in developed areas, you've got cement production for concrete. So anytime you're pouring a sidewalk, pouring the foundation of a building, making cinder blocks, anything like this for building in cities and other urban areas, that actually releases a significant amount of CO2 into the atmosphere. There might be alternatives to this, in future years, but right now it has an impact. And the biggest one we'll talk about is fossil fuel combustion. That means burning diesel and gasoline and jet fuel and coal and natural gas in power plants, vehicles, in home appliances, all of these sorts of things. All of these increase the amount of CO2 in the atmosphere very significantly. Now, there are three other classes of greenhouse gases that we're focusing on. The next one is methane, also known as CH4, which is the primary component of natural gas, the kind of stuff that you use in power plants and that you might use to heat your home. Now, methane is also naturally produced on Earth, and it is most commonly found whenever stuff is decomposing in the absence of oxygen. So at the bottom of like a bog or a swamp, because there isn't a lot of oxygen available because the water isn't moving a lot, there tends to be a lot of anaerobic respiration. And while you've learned that that can result in, say, lactic acid production or alcohol production, in a lot of these locations, the waste product is methane, and that bubbles out into the atmosphere. Now, how we've made things worse as humans is what we do with landfills. So when you have food scraps that aren't being composted and end up in a landfill, that can break down. There's no oxygen at the bottom of a landfill pile. So that gets broken down by microbes into methane, which again leaks out into the atmosphere. There are two other major sources of methane that are human-caused. One is our meat production. So when we grow cattle or sheep or goats for eating them or for dairy production, they happen to have digestive systems so that when they're eating their greens, the microbes in their guts, which again don't have access to oxygen, release a lot of methane, which they burp and fart out into the atmosphere. And lastly, and this is the one that a lot of folks don't think about, is when you extract petroleum products, when you do oil drilling, when you transport oil, when you transport natural gas through pipelines, there tends to be leaks, especially at the oil wells, especially in places where they have older technology. So, for example, in Turkmenistan right now, there's a lot of older oil extraction equipment that's leaking massive quantities of natural gas methane, CH4, up into the atmosphere. Okay, so that's the methane part, which happens to be a more powerful greenhouse gas than CO2, though less lasting. The other two categories, not directly related, but I ran out of space, which is why they're right next to each other, are nitrous oxide and HFCs. The nitrous oxide is just when nitrogen compounds, most notably our fertilizers and animal manure, is exposed to oxygen and gets broken down into this N2O gas. So again, if we are adding nitrogen to our soils using the kinds of fertilizers like ammonium nitrate, or if we're adding manure to our soils, or we're not dealing with all of the animal manure in a pig farm or a horse cattle farm or something of that nature, some of that's going to be released or turned by bacteria into nitrous oxide gas. The other impact here, the HFCs, those are actually really important chemicals that are found in all of our refrigeration devices. I'm not just talking about your refrigerator and freezer. I'm actually talking about your air conditioning systems as well, both if you have them at home and in your cars. Some of those HFCs are going to leak every year, and there's not much you can do about it, even if you have a well-built system. Okay, the reason we should care about all of these things is all of these gases in our atmosphere help the Earth retain heat. Now, to take a step back, every time light gets to the Earth's surface, every time that light gets to the surface of the Earth, that light energy is absorbed and then radiates back out. Now, some of it should and needs to be captured by the Earth's atmosphere, absorbed and re-radiated back, which keeps us warm and prevents us from being as cold as, say, Mars. If we increase these greenhouse gases too much, though, too much of the sun's light energy that's radiating off the Earth's surface gets trapped, and as that happens more and more, we warm further than we need to be warmed. The extreme version of this in our solar system is Venus, which has seen an out-of-control system that is way warmer than we currently have on Earth. So what's going to happen? Now, obviously, this is global warming. And what I want to focus on is not just the fact that it's warmer and less comfortable. That's not the biggest impact. I mean, we all have to deal with that. The real impacts are what they're going to do in terms of feedback loops. So what can we do before we get to the feedback loops? I'm going to add in percentages to see, like, every year, which of these gases or which of these activities is having the greatest impacts. Now, some of these, like deforestation or cement production for concrete, or landfill organic matter, these can have 2 to 3% of our annual impact on greenhouse gases. The ones that have a much higher impact on the world are the things that deal with, say, meat and dairy production. Combined, that's somewhere around, maybe 8% or 10%, depending on your calculations, of our total greenhouse gas emissions. That's a pretty significant chunk right there. So if humans were able to not eliminate, but at least decrease meat and dairy consumption and production, that would have a significant impact on greenhouse gas emissions. Now, again, that is culturally very difficult to do, as you know, as there are expectations about meat production and weird gender norms that deal with that as well. But this is an impact that we can have through our choices. The other, and this is the largest impact that we have on greenhouse gases, are our fossil fuels. So if we can decrease the use of fossil fuels in terms of energy production, for example, for electricity production, going with increased solar, increased wind, etc., that can have a huge impact. In addition, taking care of our petroleum extraction systems so that we don't get those leaks can also, as you can see from the numbers, make an impact. Okay, so why should we care about the global warming beyond just simple comfort? Well, if you think about it, the warming is actually going to make some of these impacts worse and worse over time. So the global warming can actually dry out, kill trees, make down trees drier, and increase the likelihood of deforestation and wildfire. In addition, you could imagine, like locally, as things get warmer, people might use further refrigeration devices, more air conditioning, more energy use to fuel those, etc. So there are greater impacts, though, globally. Some of those deal with ice. So if you imagine going further north from here and you end up in, say, northern Canada or northern Russia, there are areas on land that are typically covered in ice. The soil is actually frozen year round. That's called permafrost. But that isn't actually permanent anymore. Some of those areas are melting. As a result, the organic material, the trees from thousands of years ago, the grasslands from thousands of years ago, all of that dead material could start being uncovered and may break down, releasing methane up into the atmosphere. That is currently happening in certain northern regions, making things significantly worse. In terms of the ocean, if we go even further north up into the Arctic, some of the ice that's floating on the ocean, if it melts, will cause sea levels to rise. Now, the worst part about that is not just the fact that island nations and coastal regions might get submerged. That is definitely a problem. Even further worse than that is the fact that as ice turns into, say, liquid water, it's not as reflective anymore. The term you've learned is albedo. Once you have less ice, the Earth is going to absorb more of the light energy instead of reflecting it away. And so that's going to lead to further warming as we're not reflecting more energy away. All of these, as you can see, have arrows going in circles. These are loops. These are loops that are getting faster and faster if we don't change certain actions technologically or behaviorally. Because these accelerate, these are known as positive feedback cycles. Positive or reinforcing feedback loops, which feedback on themselves and make themselves go faster each year. There might be, if you think about it, negative ones as well. Negative feedback is where there's an action that basically makes the current trend less significant, less extreme. So you could imagine, say, as the CO2 in the atmosphere goes up, maybe plants start doing more photosynthesis, and that's absolutely happening. The problem, though, is those minor negative feedback loops are not enough to overcome all of the positive ones that I've drawn in here. I'm going to cover two other impacts of global warming really briefly. One is that as we actually heat up the oceans and have more light striking the oceans, that might lead to more cloud cover. We actually don't know exactly how that's going to impact global warming. There are two possibilities, and both, are worth considering. Depending on the type and elevation of the clouds, this might either allow us to trap more heat, making global warming worse, or depending on, again, on the type and the elevation of the clouds, might just reflect more light away, helping things a little better, making things a little bit negatively feedbacked. So that's one possibility. Another impact that deals with the oceans is the fact that some of the CO2 actually dissolves into the oceans. And some of the CO2 in the oceans, bubbles back out again too. But as we increase the CO2 in the atmosphere, therefore increasing the amount in the oceans, some of that CO2 turns into what's called carbonic acid, and that acidifies the ocean. Now, you don't need to know the specifics of what acidity is beyond the pH scale, where below 7 is acidic and above 7 is more and more basic or alkaline. That's the limit to what you need to know about acidity itself until next year when you start taking a chemistry class. But one thing you should know is that this is a problem for a lot of oceanic life. All of the organisms that you know of in the oceans and some that you don't know of, the ones that have shells, most of those shells are made of something called calcium carbonate. In acidic conditions, calcium carbonate might dissolve. More importantly, it's actually really hard to form in acidic conditions. So building a clam shell is more difficult. Building a crab shell is more difficult. Building a coral reef exoskeleton is more difficult. Even worse than that, what you probably aren't aware of is that a lot of the photosynthetic organisms on Earth, in the oceans, which is, maybe a third of world photosynthesis, most of them actually have these kinds of shells. They're microscopic. You can't see them with the naked eye, but these phytoplankton, things like diatoms and dinoflagellates, have these shells which can't be formed. As a result, if we damage those producers and some of the consumers, the result is we're going to get less photosynthesis, which results in greater CO2 in the atmosphere. And this is yet another one of the positive feedback systems that might result and are resulting from global warming. Hope that gives you a good overview. Sorry that took so long. I'll see you next time.